circuit or electric circuit. So I'm going to define this electric current. Electric current is basically the flow of.
So do I need to write this?
Yeah, you should write it.
Okay.
The flow of charge or electron or electron per unit time is called electric current, or simply current is called electric current, or we can say simply current. So please do write it.
Done, sir.
Very good. So this is your electric current. Now, this next term is basically electric circuit, or we call it circuit. So basically, we can also define it the closed path in which current or electric current flow is called electric circuit or circuit. Is that clear?
Yes, sir.
Now, with the definition of electric current, I am going to have an equation. Electric current or current is denoted by a small I. So we can write a formula. I is equal to charge or electron. Electron is also a charge, negative charge. I is equal to charge upon time. So this is the formula for electric current. And you can see, we can also write the definition. This is your current. I is current. Charge we denote it by Q, and time is T. So we can also write I is equal to Q by T. Can you tell me what is the unit of charge?
Unit of
Charge. Coulomb. I'm going to write it here.
Coulomb is K,
charge.
right, sir? If I'm not wrong.
What you just said?
Sir, what? Nothing, sir. Sorry.
You can speak up if you are confused.
No, sir. I just wanted to ask whether Coulomb is denoted by C. Okay, sir.
Yeah.
Okay.
Coulomb is denoted by C. And can you tell me the unit of time? It is second, hours, minute.
Yes.
So unit of time here, we generally take seconds. Okay.
Okay, sir.
So the unit of current.
So is that capital C or?
Yeah, this is your capital C, this is your small s. Unit of current will be coulomb per second, and we call it ampere. We call it ampere. To honor the scientist Ampere, the unit of current is on that scientist.
Okay. Okay, sir.
Done.
Yes.
Now you can see you have now a formula, that is I is equal to Q by
Q
T.
upon, yes. Hello, sir. Hello.
Azan, are you there?
Yes, sir.
I was just got disconnected due to network issue.
Okay, sir.
So, mm, are you able to see the screen now?
Yes, sir.
I'm going to show you a diagram of a circuit from NCRT. So see, Azan, this is your basically this is your battery.
Right.
This, and always remember that the positive terminal of the battery will be larger than the negative. The small one is the negative terminal of the battery, and the larger one is positive terminal of the battery. This is your switch. This is your switch. This is your ammeter that measures current. This
Mm-hmm.
is your ammeter that measures current.
Okay.
Also, it's very important to note that this is how we denote electric bulb. This is how we denote electric bulb. If the
Okay.
switch is closed, if the switch is closed, then you can see the current flows from positive terminal of the battery to negative terminal of the battery. Are you
Mm-hmm.
getting my point? You
Yes,
can
sir.
see it is flowing from positive terminal of the battery to negative terminal of the battery. And always remember that the flow of electron is opposite to the flow of current. If current is flowing from positive to negative, what will be the direction of electron? It will be negative to positive. Is
Okay.
that clear?
Sir, what is electron here? How would you define
Electron
it?
is negatively charged.
Okay, right.
Electron is negative charge.
Yes,
So
sir.
negative charge is basically move from right to left, then current will flow from right, left to
Left to
right.
right. Okay.
Is that clear? Now I'm going to give you a question on this. And this question is basically based, it is from NCERT. And the question comes here. Are you able to see the question?
Yes, sir.
A current of 0.5 ampere is drawn by a filament of an electric bulb.
Sir, 300 column? Oh, how do you pronounce it, sir? C. How do you pronounce C, the
Coulomb,
unit? Coulomb. Okay, sir.
Coulomb. Yeah, it is based also upon a scientist name. So current I is given as 0.5 ampere and time t is given as 10 minutes.
Which you will
So you need
convert
to convert this in second. So
600.
1 minute equals to 60 seconds. So it will be 600 seconds. Now you need to calculate charge.
Sir,
So I
it's
is equal
300.
to Q by T. It's 300.
No, sir, the answer is 300. Q is equal to 300.
Okay, okay. I is equal to QT. So Q will be equal to I into T.
Yes, sir.
I is 0.5 ampere. So we can write 5 by 10 ampere into 600. So it will be 300 coulomb. Is that clear?
Yes, sir.
Very good. Now I'm going to ask another question from you. And that question is very important and it is also from your NCRT. And the
Okay.
question comes here. Are you able to see the question?
Yes, sir.
Calculate the number of electrons constituting constituting 1 coulomb of charge.
Hmm. Hello, sir.
Yeah, yeah.
Sir, how am I
Will
supposed
you
to
be able
find?
to explain? Okay.
No, sir.
See, this question is very important when you will go in higher classes in class 12. So you will be learned that charge is quantized, or this sentence can be understood like the charge in the universe will be exist, which is integral multiple of E, which is integral multiple of E.
So,
So
what is
Q will be
integral and
equal to
multiple?
NA. Yeah, I will just explain. Just see. Can you
Okay.
do you know what this E is? E is basically charge on electron. E is basically charge on
As an electron.
electron, which is basically 1.6 into 10 raised to the power minus
Minus
90
19.
coulomb. Okay.
Right. Yes.
Now, if I will say that Q is equal to 3.2 into 10 raised to the power something coulomb, like 5 coulomb, and I will ask whether this charge exists or not. So what you are going to do, You are going to put the value of q here. That means 3.2 into 10 raised to the power 5, and that is equal to n into e. E has a value 1.6 into 10 raised to the power minus 19. Let's say n will be equal to 3.2 into 10 raised to the power 5 upon 1.6 into 10 raised to the power minus 19. So if they will be cancelled and giving you an integer, like this will be cancelled 2 times, yes or no?
Yes, sir.
So you can see you just got the value of n as not as fraction but as integer. So you can see if you are going to solve it, you will be getting like 2 into 10 raised to the power 24. So the n is integer, yes or no, positive integer.
Yes.
That means this exists, and this is what we say the integral multiple of e. Basically, the value of charge should be integral multiple of e. Like if I'm asking you, 10 is integral multiple of 5 or not? Yes, it is, because 5 2 is 10.
10.
Are you getting my point?
Yes, sir.
12 is integral multiple of 5? Yes or no?
No, sir.
No. And if you have got q is equal to, let's say, 2.2 into 10 raised to the power minus 19 coulomb, you can apply the formula n is equal to q upon e. You know the q is given as 2.2 into 10 raised to the power minus 19 coulomb, and e is what? 1.6 into 10 raised to the power minus 19. So will it be cancelled? There will be fraction, because if you are going to
Yes.
cancel it, it will be 1.1 upon 0.8, or eventually you will be getting 11 by 8, which is fraction, not an integer, right? So
Yes.
this charge will not be possible. All I want to say is that you just need to remember this formula q is equal to ne, and the charge which is integral multiple of e will exist. Okay.
Okay.
This is the
Sir,
concept
what if
behind
the
it.
number is
And
in negative? If the number is negative,
yeah, that doesn't matter.
that doesn't
See,
matter.
charge
Decimal?
charge is, if decimal is there, that also does not matter until they will be cancelled and gives you integral multiple. Like you can see, there is a there was a decimal but it got cancelled. There is a decimal but it didn't get cancelled. So this is not true. Are
Okay,
you
sir.
getting? N should be
Yes.
positive integer or negative integer, it can be, but it cannot be in decimal or fraction. If it is in decimal, that means it is in fraction, right?
Yes.
All I want to say is that you need to remember this formula q is equal to ne, and you know that in the question it is given that find the number of electrons that constitute 1 coulomb, that means charge is 1, and we need to calculate n, 1 coulomb of electron. What was the question?
One number of electrons constituting 1 coulomb of charge.
1 coulomb, number of electrons. So, what is the charge on 1 electron? That is 1.6 into 10
1.6
raised to
into.
the power 19. So, n is equal to 1 upon 1.6 into 10 raised to the power minus 19. And if you are going to solve it, I think you will be getting 6.25 into 10 raised to the power 18 electrons. Is that clear?
Yes, sir.
Can we move to the next part?
Just a Then how did we get 6.25? Could you just
When you are going to divide it, like you can see 1 upon 1.6. See, 10 raised to the power 19, when it will move up, it will be in positive, right?
right
So if you're going to remove this decimal, it will come
into
here
10?
and it will eventually go in the
Right.
numerator like this. Okay. Now
Okay.
what you need to do, you need to divide this. You can also count, cancel it. So it will be 5 by 8 into 10 raised to the power minus 19. Now
Okay.
you are going to divide it.
Okay, sir. That's it.
8 6 48. Have you got?
Yes, sir.
Okay, so do you wanna go now?
I have 5 minutes, sir. If you want, if the topic can get
Yeah,
over
yeah.
around.
This topic is over. We are going to start a new topic, that is electric potential. That's why I asked.
Okay, sir, but I was. It would take me like a
Okay,
bit, sir, because I don't know the exact time. Sometimes it switches time. So
okay,
in
okay, no
if
problem.
it's 5 minutes, I'll go in 5 minutes. I guess.
Okay, electric potential and potential difference. Now I'm going to ask you a very simple question. You have two container or water tank, you can say that. Okay, you have
Yeah.
two container or water tank that is of same, what we say, basically same width, length, and everything. Okay, let's suppose
Okay.
that they are same. Now if you are going to connect these tanks like this, and if you are going to fill this left tank, if you are going to fill this left tank with water, with
What?
water,
Okay.
so what will happen? This will be filling with water. At the same time, what will happen? What do you think?
So the other tank
Water
will
will
also be filled.
start, yeah. And let's say there is nothing, but this was initially filled, and after that we made this hole in the second container, and then water will start flowing in this.
Yes.
Are you getting my point? Can you
Yes.
tell me when will be the flow of water stops? When will be
When
the
the
flow of
what
water stops?
when the water reaches below the point of the hole.
Below the point, that
So like
you mean
basically I've
that
drawn two lines right
the,
below those
yeah,
two lines.
yeah, all you want to say is that this water will come here and it will,
Like, yes.
then it will the flow. No, use your common sense. If there will be more water, then flow will be from left, right to left.
Come again, sir?
Hmm. You want to say that the water flow will stop when the water level in the left will be like this, below the hole, and this is what you want to say,
Wait, so the
right?
water will flow there. The water continues to flow, I'm guessing.
No, see, yeah, you can say that, but if you want to see, the flow of water will stop if they will be coming at the same level. We can say that.
Okay.
Because if you want to say that if this will come below, it will not go, because at this time if this is going below this, that means you are applying pressure, जबरदस्ती से आप इधर भेज रहे हैं. That means, are you getting my point? You are going to
Yes.
do an experiment. Just take a two bottle, plastic bottle, and hold them. Fill it, one filled with water and another just empty bottle. Then you will see it will start flowing from left to right until they come at the same level,
Right.
because of some pressure, you can say. Pressure will be applying from both sides the same. So if the force or pressure applying from both sides in opposite direction are same, it will eventually, the net pressure will be zero. Are you getting my point?
Yes, sir.
This is how electric potential works. What is electric potential? So potential is the, basically what we can say, uh, ability to move charge from one point to another point. Are you getting my point?
Yes.
The same concept we are going to use in electric current, why electric current flows. So it's all because of this potential. If the potential difference, you can take this 2 as, or you can take this 2 point as the container. If they have same potential, that means potential difference will be zero, and hence the current will not flow. What I want to say is that if you have two container and
Sir,
they
sorry
are
to
on the
interrupt,
same level.
but sir, can
Yeah,
I
this
go
is
right now?
your
I'll
time.
just be back as soon as I can, sir.
Okay, okay, okay.
Sorry for
Okay,
that, sir.
okay. Take
Thank
your
you, sir.
time. Don't be in hurry. Hassaan. Let me know when you join.
Hello, sir. Sorry for that, sir. I'm back.
No problem. Are you there?
Yes, sir.
Okay. So I was uh, going for this electric potential and potential difference. Now is
Right.
the time to I'm going to define what is this potential means or electric potential potential difference means. So I'm going to define, just write with me, electric, or is you can easily say potential difference also. Electric potential difference between two points in an electric current carrying in an electric current carrying. Oh, wait a minute, I'm just making it complicated. Sorry.
Okay.
We can directly define potential difference is defined as, or electric potential, both are same. Potential difference is defined as work done to move a unit charge from one point to other. So it's very simple. Potential is also work, but it is work done to move a point charge from one point to another. So we can easily write the formula and equation from this potential difference that we are going to denote it by V between 2 points between 2 points is equal to work done to move the charge upon per unit charge basically. So it will be charge that is denoted by Q and work done is W. So we can get a formula of potential which is V is equal to W by Q. Now the unit of work is joule and the unit of charge is coulomb. So this is the unit of potential difference or potential. Also, this is known as joule per coulomb is known as volt. That is denoted by V. Is that clear? So the
Yes, sir.
unit or SI unit we can write here. SI unit of electric potential is volt. That is V. Please do write. And we got a formula on which we are going to do a question.
So, SI unit of electric potential is volt. Yes.
Yeah, either you can call it joule per coulomb, but it is known as volt. Like coulomb per second is the unit of current, but its name is ampere.
Okay. So could you scroll? Yes.
Yeah, I'll just scroll it. Yeah, what do you want me to do? Scroll up.
No, sir. It's fine.
Let me know so that I'll slide it down.
Done, sir.
No. Now, please apply this formula and do this question. It's very easy.
Okay, sir. Um, So 24 Joule.
Oh, very good. 24. So what you just did, W is equal to, basically we have V is equal to W by Q. So
Yeah,
W will
W is
be
equal
equal
to
to
V into
V
Q.
upon, sorry, V into Q. And V, you know that 12 it is,
12.
and this is your 2. So it
Mm.
will be 24. Okay.
Yes, yes.
That's very good. Very good. Now I am going to give you three questions. Actually, I am just covering the question with the topic as well so that we can have test
Right,
in there.
okay.
Are you able to see the screen?
Yes, sir.
There are three questions that I'm giving you. You can easily do this, right?
Uh, so how much energy given? So the third one, how much energy is given to each coulomb of charge passing?
Energy and work are interrelated. Do you know the unit of energy is also joule?
Yes, yes.
If you have 10 joule of energy, you can use that energy to do the work for 10 joule, right?
Not getting the point, so sorry.
Okay. And let's say if you have 100 joule energy, you can do a work up to 100 joule.
Yes,
So basically, the energy that you calculate, it's same as work. They are interconvertible. Like if you have 100 rupees, you can spend on anything up to
right.
100.
Yes.
So that money is directly proportional to the
Okay.
expense of your up to that point, right? So if
Okay.
you are calculating work or energy, they are same almost. Okay.
Okay. How much energy is given? Energy is basically, sir, work done, right?
Yeah, yeah. That
Okay.
is what I want to.
So, sir, it would be 6 joules.
Very good.
Sir, if charge isn't given, right, we
Each
take it as
coulomb,
each. Okay, okay, got it. So one.
each
That's all.
one coulomb.
Yes.
So work or energy will be equal to 1 coulomb into 6 volt. That will give you 6 volt coulomb. That is equal to 6. What about the first one? See,
Sir,
current
that.
measures by current measurement by a device that is known as ammeter. That is known as ammeter,
Um,
and to maintain the to name the device that maintains the potential difference, that is voltmeter. That is voltmeter. Always remember that.
volt.
Okay.
Okay. Yes, sir.
What about this?
So just a second, I just want to write it down.
Oh,
Volt. What is meant by saying that the potential difference between what is 1 volt?
let me know if you are unable to solve.
Right? Yes, sir. Please. I don't
Okay.
know how.
See, potential difference has a formula W by Q. How will you get the value 1V? It is only possible when you are going to do a work for 1 joule and for a charge of 1 coulomb. That will give you 1 joule per coulomb. That is known as 1 volt. So this is the mathematical expression that I expressed. Now we can also define 1 volt is defined as when 1 joule of work is done to move a charge of 1 coulomb from one point to the other. There is no E. From one point to other. Is that clear?
Yes, sir.
Please do.
Yes, sir. Done.
Now we have circuit diagrams. Some of them are important to recognize which circuit diagram is this. And you can see this. A cell, electric cell is represented by this positive terminal or negative terminal. But if you want to represent a battery, which is group of cells, group of cell is battery. Are you getting my point?
Yes, sir.
So this is your battery, a battery, you can see plug. This is open, that means switch is off. This is closed, which means dotted line. It is closed, that means on. A wire joint, that is not that much important, but you need to. A cross joint, an electric bulb, a resistor, which is very important, and a resistance, or also known as
Rheostat.
resistor. Basically, it is variable resistance. This is variable resistance according to our requirement. We increase or decrease. And a normal resistor, that is a one-time fix, is this. This is available in NCRT. Okay.
Yes, sir.
Okay. And also this part. Wait a minute. This ammeter and voltmeter is also very important. This is the representation or symbol of ammeter and voltmeter. Is that clear?
Okay. Yes, sir.
So this is very easy, right?
Yes, sir.
Now we are going to start a very important law of this chapter, that is Ohm's law. Ohm's law. So I'm going to write a point about this, then I'll explain. According to this law, the potential difference V across the ends of a given wire. Or you can write metallic wire. That is understood. Sorry.
Okay.
Wait a minute. In an electric bulb, oh sorry, in an electric circuit, is directly proportional to, this is important, is directly, I'll explain it, just write with me, is directly proportional to the current flowing through it, provided its temperature remains same, remains same. That means basically temperature should be constant, T constant. So first you are going to write it, then I'll explain it.
Done.
Very good. Now see, the potential difference that is present in an electric circuit or circuit is directly proportional to I, is directly proportional to I. That means if you are going to increase the potential difference between two terminals of a conductor, the current also increases. To remove this proportionality sign, we are going to use a constant, that is R.
Sir,
R is
sorry,
equal to
could you
resistance.
please repeat again? Sorry, sir.
Yeah, I'll just repeat it. See, if you have 4 volt and 2 ampere current, and if you are going to increase this to 8 volt, the current will also increase. You know
Yes.
what is directly proportional? If one of the quantity will increase, another will also be increasing.
Okay.
So basically in a circuit, if you have V potential difference and I current, so if you are going to increase that potential to 2V, the current will also be doubled. That means basically potential difference is directly proportional to current. Potential difference is directly proportional to current,
Correct.
and this proportionality sign we are going to remove with a constant, and this is R, which is resistance. Is that clear?
Yes, sir.
So we got a formula, V is equal to IR. V is equal to IR or RI, you can write. So I will be equal to, you can write V upon R. R will be equal to V upon R. Oh, wait
V
a minute.
upon I, right?
V upon I. Yeah. Wait a minute. Please do write it. Let me know when you are done with this.
Yes, sir. Done.
Okay. So what is this resistance, which is a new term for you, right? In this chapter, we just introduced this resistance. And resistance, you have seen, this is the how we represent resistance. So
Right.
resistance, it is property of conductor, property of conductor, which resist the flow of, which resists the flow of current. That means basically potential is a quantity, or the not a quantity, but a, what we say is a property which resists the current, which does not allow the current to flow.
Pass. Flow.
Is that clear?
Yes, sir.
Please do write it. And unit of current is, sorry, unit of current you already know, ampere, and the unit of potential difference is volt. So R will be equal to V upon I, which is volt upon ampere, which is known as ohm, which is known as ohm, and
Oh,
we denote it by ohm.
right.
So this is very important. You don't need to write the unit of resistance as volt per ampere, but you need to write the resistance of, sorry, unit of resistance is ohm.
Okay, sir. unit. R is equal to V upon I.
Yeah. So
Potential.
unit is what is V? V is here potential, which is also
Right.
denoted by V, and
Yes.
volt is also denoted by V. Okay.
Okay, that's volt. Okay, sir. Okay.
Yeah, V is here for volt, and here it is for PD. That means potential difference. Don't be confused about this.
Yes.
Let me know when you are done with this.
Done, sir.
Okay, so I'm going to give you a question on this. Let me give you a very simple question. The PD, that is stand for potential difference of a circuit. It's 60 volt, which carries 15 ampere current. Calculate resistance. Calculate resistance.
Okay. Sir, 15 ohm.
15.
Wait. Okay, sir. I wrote it correct, then I wrote
Wait a
it
minute.
wrong.
Yeah.
No, sir, I
Okay,
wrote the
just let me
question
check it.
wrong. Never mind.
60 volt it is, 15 ampere.
Right. Okay. No, sir, I got something. I wrote IS.
IS.
15. Sorry, just. Sir, the answer is 4. 4
Yeah.
volt. Ohm, 4 ohm.
You know V is equal to IR. You know this is given 60, I is given 15, and here your R. R will be equal to 60 by 15. That means 4 ohm. Is that clear? Very good.
Yes.
Now you are going to do this question. A part, it has two part, and B part. How much current will this be drawing?
How much current, right?
You can read it.
Volt we have I. Sir, 22,000.
There are two parts in this question, A and B. Uh,
Oh wait, I did the second one, sir, because we have resistance, we have current, right? So
no, we don't have current.
no, we have to find current. Yes.
We have to find current in both.
Okay, sir. Then I wrote the thing. Okay, sir. So I is equal to V upon V upon. So 2.2 is no, I'm correct. So is it 2.2 for the second one? 2.2
Yeah, it is.
A. 2.2 ammeter
Ampere.
or no,
Ampere. Ammeter is a
ampere.
device.
Okay, ampere. Okay, sir. And the first one is 220. So do I need to do the first one as well?
Yeah, yeah.
Okay.
Both of them.
Sir, I got a pretty okay. I got 0.183.
Yeah, it's wait a minute, let me just divide it. What you just said, 0 point?
183.
Yeah, it is good. It is good. So you are able to solve the for this type of question. You know, I is equal to V upon R, right? So 200 upon 1200, that will be 0.18 ampere. And for the second one, you know that I is equal to V, that is 220 upon R is 100, so it will be 2.2 ampere, right?
Yes.
That's good. That's good. Now I'm going to give you another question. And here the question comes. Are you able to see the question?
Yes.
The potential difference between the terminals.
Okay, we have V, we have I. That is if the potential difference is increased to 120 V, what current will the thing? That would be 120 upon 2. Okay, so the first one, oh, we don't need to know. Okay, so it would be 120 upon 15, which is equal to 8 amperes.
Where is the 15 given?
So it's not given, I found it.
You found it, so you should
Oh, sorry, sir.
tell me first. So no problem.
Okay.
Potential difference is 60 volt.
60. I is 4.
I is 4.
4.
I is 4. So you calculated V upon I. That is equal to 60 upon 4. That is equal to 15 ohm, right?
Oh, yes.
Now, potential is given. Now you increase the
Potential.
yeah, and this resistance in the same wire, that means resistance is same. So I will be equal to V upon R. That will
Which
be
is
equal to
120 upon
120 upon 15. So it will be
15.
8 ampere. Done.
Yes,
Can
sir.
we move to the next part? So basically, this chapter is very, very easy. In the next two classes, that means in coming week, we can easily cover this chapter. But
Sir, is there any deleted portion from this, or is it the whole thing?
actually, I have to look into it. Okay.
Okay,
I
sir.
don't know yet.
No, I don't think there is. No. There is no. It was some
Now
other
see,
chip.
yeah, yeah. But you, I'll check it. Okay.
Yes, sir.
Factors on which resistance of conductor depends.
Do I
Resistance
need
of
to
conductor.
write this?
Yeah, this is a topic. Please do write.
Factors.
Done?
Yes.
Yeah. So factors on which resistance depend. The first is one is resistance that I'm going to denote it by R is directly proportional to L. L that means length of conductor. Length of conductor.
Conduct.
If you are going to increase the length of the conductor, resistance also increases. The second
Length
one is
of the conductor, sir. I
length.
don't know. If you increase
What?
the length of the conductor,
See,
what is
you
a
have
conductor? How do you say it?
conductor that means wire.
Okay, okay, sir.
Are you getting my point
Yes, sir. Yes.
now? And, and resistance is inversely proportional to area. That means if you are using a thin wire, it will have more resistance. And what does resistance mean? Resistance is a property of conductor which resists the flow of charge, flow of current. Okay. And if you are using a thick wire, the current will flow more. Are you getting my point?
Yes.
Area of cross section of wire or conductor.
Area cross.
Done.
Yes, sir.
Now see, we are going to combine this both. So L upon A it will be yes or no?
Yes.
Resistance directly proportional to length and inversely proportional to area. Now to
Okay.
remove this proportionality sign, we are going to use a constant which is denoted by rho, and this is your this quantity is constant which is known as resistivity. This is your resistivity, or we also called it a specific resistance. And for a particular type of wire like copper, zinc, for a particular resistivity is constant. Is that clear?
Yeah. For a particular.
Like you are using copper wire, so its resistivity will be constant. If you are using an iron wire, its resistivity will be constant. Are you getting my point now?
Yes, sir. Resistivity. There's a okay. Perfect. Resistivity of specific resist.
Its name is this is the symbol that we call it rho, and rho is basically resistivity or a specific resistance. Its name is. Are you getting my point?
Yes, sir.
Okay. This is the symbol for resistivity. Done.
Yes.
No. So we just got a formula for resistance that is equal to rho L by A. Can you tell me the unit of resistivity rho? Unit of rho?
Unit of rho.
Yeah.
Is it also ohm?
No. You need to calculate it before saying just calculate it. I'm going to write the formula from this. Can I write rho? Resistance into area upon length for rho. Can I write
Yes.
this?
Yes.
Now see, what is the unit of resistance? That is ohm. What is
Ohm.
the unit of meter? Area, that will be meter square. What is the unit of length? That is meters. So meter and meter will be cancelled and we will get ohm meter. So this is the unit of resistivity.
And what is it called, sir?
Ohm meter. This is ohm. This is meter.
Ohm meter or ohm minus meter? What is it?
No, no. This is hyphen. Ohm
That is
meter.
hyphen.
Are you
Okay.
getting my point?
Yes,
Not
sir.
meter.
Yes.
Yeah, hyphen.
Okay, sir.
So this is it for today. In the next class, we are going to do some numericals. I will send the screenshot of the question, and I had seen that some of the you sent some messages and then deleted.
Sir, it was related to this, the book thing, sir. It's fine.
Okay, you shouldn't have deleted. No problem. I just sent you the question from NCERT. Okay. In the next class, you are going to read about the series and parallel resistance. Okay, resistance of a system of register. So we will look into
Okay.
it on Tuesday, right? On
Yes, sir.
Tuesday we have a class.
Yes.
Tuesday and then Thursday. Yeah, we can easily complete this chapter in this week. Okay.
Okay, sir.
After this chapter, human eye and the colorful world.
Human eye. So just a second. Let me have a look.